Welcome, my friends. In this video, I'll be discussing section 2.3, which is titled Two-Way Tables. If we would like to consider two variables related to a single individual together, we have what is called bivariate data. If both variables are categorical, then this data can be summarized on what is called a two-way table, sometimes called a contingency table. This is what that table looks like. Our two variables in this case are worker type as either executive or production worker, and political affiliation as either Democrat, Republican, or Independent. Inside the table, we have the number of individuals who have each combination of the row and column variable. For example, we have 5 individuals in the sample who are both executives and Democrats. We have 9 individuals who are both executives and independent. We have 21 individuals who are both production workers and Republican, etc. The row total represents the total number of executives, 48, or the total number of production workers, 92. These numbers can be found by adding the numbers in the 3 columns before them. So 8 plus 21 plus 63 is equal to 92, and 9 plus 34 plus 5 is equal to 48. The column total represents the total number of individuals who have each political affiliation. So we have 68 Democrats, 55 Republicans, and 17 Independents in our sample. These values can be found by taking the previous 2 rows and adding them together. So 8 plus 9 is 17, 21 plus 34 is 55, and 63 plus 5 is equal to 68. Finally, the grand total is 140, which represents the total number of individuals in our sample. You can find this value by adding the 2 numbers right above them, 92 plus 48, or by adding 17, 55, and 68 together. In this class, we will always let the rows, in this case worker type, represent the explanatory variable, also known as the independent variable, and we will let the columns, in this case political affiliation, represent the response variable, also known as the dependent variable. This means that we may have the belief that worker type has some sort of influence on political affiliation. For example, we may have the belief that executives are more likely to be Republicans than production workers. Note that in other textbooks or in other two-way tables that you might see presented, we will not always necessarily see the explanatory variable on the rows and the response variable on the columns, but that's the convention that we're going to be using in this class. When you hear the term observed cell count, that just means every value on the inside of the table. So that would be these 6 numbers right here. For example, from the sample, we observed 5 executives that were Democrats, the very first value. Now, instead of expressing a two-way table using observed counts, we can express each cell as a proportion of the total sample size. This is what we call the joint distribution of the 2 categorical variables. Here's our initial table with the observed counts. If we would like to find the joint distribution, take each cell count and divide by the total sample size, in this case, n equals 140. If you do this, this is what the table will look like. Let me show you an example of how a few of these numbers are calculated. To find the percentage of individuals who are both Democrats and executives from our sample, we can take the 5 and divide by our sample size, which is 140. We'll get 0.0357 approximately, or if we multiply by 100, we will get 3.57 or 3.57%, which tells us that 3.57% of the total individuals in the sample were both Democrats and executives. We could do the same thing for every single value in the table. So for example, we could take the 21 Republicans, who are also production workers, and we could divide by the grand total of 140. We would get 0.15, which when we multiply by 100, we get 15 or 15%, which tells us that 15% of the total individuals in our sample were both Republicans and production workers. In the joint distribution, each value is thought of as a percentage of the grand total. And this also applies to the row totals and the column totals. So we could say that 34.29% of the individuals in the sample were executives, or 65.71% were production workers. These 2 numbers together should add up to 100%, since our entire sample only included executives and production workers. We could also apply the same logic to the political affiliation. 48.57% of the individuals are Democrats, 39.29% were Republicans, and 12.14% were independents. And those 3 numbers should also add up to 100%. Okay, we have one more distribution to talk about, which is what we call the conditional distribution. The conditional distribution tells us how likely an individual is to be part of each column of the table, given or assuming they are part of a specified row. Here's our initial two-way table with the observed counts. If we would like to find the conditional distribution of political affiliation given worker type, we will take each cell count and divide by the row total, which will be either 48 or 92. This will be the result. So let me show you how a few of these different values could be calculated. If we grab our calculator again, we could take the 5 individuals who are both executives and Democrat and divide this time not by the grand total of 140, but now by the row total of 48. The result will be about 0.1041, or if we multiply by 100, about 10.42%, rounded to 2 decimal places. What does this number mean? Well, before, when we talked about the joint distribution, each value could be thought of as a percentage of the total. So the 3.57% represented 3.57% of the total individuals were both Democrats and executives. So what does this number, 10.42%, represent? Well, remember that we have the conditional distribution of political affiliation given worker type. So given worker type means we're really only considering one worker type at a time. So for the row of executives, we're only considering the executives. Out of just the executives, what percentage are Democrat? Well, 10.42%. Or out of just the production workers, what percentage are Republican? Well, that would be 22.83%. Note that the row totals should technically add up to 100%, but due to the rounding, the total for production workers was a little bit over 100%. So to reiterate here, each value in the conditional distribution can be thought of as a percentage of the row total. So for example, 10.42% of just the executives were Democrats. Note that you might see the word given represented by a vertical line. So we could say that the chance of someone being a Democrat given their worker type is executive is about 10.42%. Okay, so now that we have the conditional distribution, there's one more thing that we can do. The conditional distribution can be used to assess the independence of the variables. So what does that mean? Well, our two variables, which are worker type and political affiliation, would be considered independent if executives and production workers were approximately just as likely as each other to have any given political affiliation. Worker type and political affiliation would be dependent if either executives or production workers would be more likely than the other to have a particular political affiliation. So we could ask ourselves, are worker type and political affiliation independent or dependent based on our conditional distribution? Well, in this case, they are not independent. Production workers are much more likely to be Democrats than the executives are. If we look at the numbers here, we can see that 10.42% of the executives are Democrat, whereas 68.48% of the production workers are Democrat. In other words, if you're an executive, you are much less likely to be a Democrat than if you are a production worker. So we could say that your political affiliation depends in some degree on if you are an executive or a production worker. Now, usually independence or dependence is assessed across the entire table. So all that really means is we're comparing how close together each values are in each column. So how close is 10.42 to 68.48? Well, those are quite a bit different. The production workers are a lot more likely to be Democrats, so that's leading some weight towards dependence. Same thing with the Republicans. The executives are much more likely to be Republicans than the production workers, so we have a big difference here as well. And same with the independents. We have a big difference between the percentage of executives who are independents versus the production workers. So no matter where we look, we see a big difference between the executives and production workers. So that's going to lead us to saying that these are most likely dependent variables. If they were independent, we would see very similar percentages in each column. Finally, note that dependence does not necessarily suggest a causal relationship. We are not saying here that your worker type causes you to be a Democrat, Republican, or independent. We're just saying that individuals who are, for example, production workers tend to be more likely to be Democrats. But we're not saying that being a production worker will cause you to be a Democrat. That would be a further step that would not be able to be determined just based on a two-way table. All right, so here is a problem for you to try. We have the expected grade in an intro stat class as either an A, B, or C. And we have this for both females and males. So you are asked to find the joint distribution and the conditional distribution of expected grade given gender. So as a reminder, to find the joint distribution, you'll take each value and divide by the grand total. And for the conditional distribution, you'll take each value and divide by the row total. So go ahead and give that a try. And once you're finished, that is all that I had to talk about in this video, so I will see you in the next one.